This is lesson number 4 on conditional probability. We'll talk about the meaning of conditional probability and what the rule for conditional probability is. Conditional probability is the probability that an event occurs given that another event has already occurred. Basically, it means you've been told some extra information which reduces the amount of sample space you need to consider to work out the answer. There's a rule, and we read this rule as probability of A with vertical line given that B has occurred. So we say probability of A given B is equal to the probability of A intersecting B divided by the probability of B. Note that the probability of A intersecting B is the same as B intersecting A. It describes the same thing. Think about our Venn diagrams, the two circles overlapping. A intersects B is the same as B intersecting A. If the rule had other symbols, not just A and B, so for example might be A given not X, then we follow the same order here. So A given B is A intersecting B. A given X naught is the probability of intersecting A and X naught. B given B, so probability of B goes in the bottom. Given X naught, probability of X naught goes in the bottom. So you follow the same order. Let's have a look at several different examples and different approaches to doing conditional probability questions. So we've got a Venn diagram here. You can see here the two events are A and B. There's 9 in total here. So the probability of A is made up of two sections, A only and the intersecting with B. There's 5, so the probability of A is everything in that circle there, so it's 5/9. Probability of A intersecting B is what belongs to both. So this diagram indicates that. So in this here it's 2 out of the 9. Now here's our first conditional one. Probability of A given B. So if you think about this as B has already occurred, so I can ignore that part and that part. We only got to consider the circle B. Now, what's the chance of also belonging A? Well, it's 2 out of the total of 6. Because there's 2, what's probably being A, given that it's only to look at B. That's what the given means. Reduce what you look at. And the other way, what's the probability of B given A? Well, we only consider the A circle. What's the probability of being B? It's that intersection there. So it's 2 out of 5. So that's one way of doing conditional probability. That's using diagrams and not the rule. Here we'll do an example where we use the rule. So the question here is what's the probability of rolling a 3 given that number is odd? This implies that we're looking at a 6-sided die. So the first thing you say, well, you notice it's the word given here. It tells us a conditional probability. Sometimes the word if occurs, so that usually tells us conditional. So the first thing, what do we need to find? It asks me what is the probability of rolling a 3. So we let that be event A. A is the 3 is rolled. Then what's the given information? The number is odd. So B would be an odd is rolled. So we've set this out in symbols. Probability that 3 is rolled given an odd is rolled. So probability A given B, which we work out as the probability of A intersecting B over the probability of B, because that's using the rule. Probability of A intersecting B is probability of being a 3 and odd is 1 out of 6 on a die. Probability of being B, what's probability of being odd, is 3 out of 6. Now that says 1/6 divided by 3/6. You can work it out this way. It's 1/6 times 6 on 3. Remember, we flip a fraction if we can't do a division. The 6's will cancel that. I'm left with 1/3. There is a shortcut. If the two denominators of a fraction divided by another fraction are the same, then the answer will be that numerator over that numerator, 1/3. It's a shortcut. Example 3. Here we're starting with a two-way table. which is incomplete, so the first thing we need to do is complete it. Obviously 3 will go in that spot, 5 plus 3 makes 8. 12 would belong in this spot because 8 and 12 make 20. If that's 12 there, then that would be 8 here, make 13, means that's 7, etc. So we work out, complete the two-way table. Now we can answer the question. Probability of A, what's the probability of A? It's 8 out of 20, which can be simplified because 4 is a common factor of both those numbers. So 2 4s is 8 and 5 4s is 20. Probability of B, we go to the B row. Chance of being B, there's 13 in B out of the 20. Can't be simplified. Probability of A intersecting B means belong to both A and B. So it's 5 out of 20, simplifies to 1/4. Okay, here comes our conditional probability questions. We can do this two ways. We can use the rule up above here, or we can consider what it's actually saying to us. What's the probability of being A given that it's in B? Well, the probability it's in A, but we're only considering the B, so it's 5 out of the 13. Or, if we use the rule, probability of A intersecting B is A given B is the probability of A intersecting B, 5 out of the 20, divided by the probability of B, which is 13 out of the 20. If you notice that there are our last two answers. And a little trick before said the answer here will be 5/13 because the denominators are the same. This one says not A given B. Well, this is not A given B, so the answer should be 8/13, or we go 8 out of 20 divided by 13 out of 20, which makes 8/13. These are the questions we need to do on conditional probability. Good luck.